All right, here's a couple sample problems I want to look at. And this will give us a good example of how to apply some of the expressions for momentum. Okay, so I have a 2 kilogram cart moves to the right, okay, a certain speed, has a head-on collision with another cart that's moving to the left, okay, they give me that speed, and then it says after the collision, the first one heads to the left, and they want to know what happens to the second one. Okay, so for notation purposes, okay, so my before picture, because remember, for momentum collision problems, you need two diagrams, before diagram and an after diagram. So for notation purposes, I call this one M2. And then I call this one M5. Why not call them M1 and M2? Well, if I call this one M2, then I never have to look up to see what the mass is. That mass is 2 kilograms. This one I called M5, and I remember that the mass is 5 kilograms. Okay, so going through the problem, they say number 2 is headed to the right. Okay, so I wrote down a V2 initial, and then the second one, number 5, is headed to the left. So I wrote down that on my diagram. So initial velocity number 5 is -2. It's headed to the left. Okay. In the after picture, it tells me that the first one heads to the left. So V2 final is -2, heads to the left. Just using a regular coordinate system. Left is negative, right is positive. And they want to find what's the final velocity of the 5 kilogram one. So we have no idea which way it's moving. Okay, so we conserve momentum for the system. So I wrote P2 initial plus P5 initial equals P2 final plus P5 final. Okay, and remember momentum is mv, so for each of these terms I wrote mv for that, mv for that, mv for that, mv for that. Okay, and then all I did is obviously here I never have to look back up the problem. I know M2 is 2 kilograms, M5 is 5 kilograms, but looking back at the picture, V2 initial 6, okay, in the correct units, V5 initial, that's my -2, I just wrote that there, my V2 final, -2, and then just solve this algebraically for V5 final. And then just do that on a calculator, and I get that, and it's positive, which means number 5 moves off to the right. Okay, here's another similar problem. So I have two objects coming at each other. They gave me the masses, okay, and again, this one was 2 kilograms, so I called it M2. This one was 5 kilograms, I called it M5. They gave me the velocities, okay, and then it says they suffer a completely inelastic collision, okay. Inelastic means kinetic energy is not conserved, okay. So we saw that also in this week's lab, that when two things have an inelastic collision, that kinetic energy is dissipated by some type of friction force. Completely inelastic means that they stick together, all right? So they want to calculate the magnitude of the kinetic energy lost during the collision. So I did an example in the notes where I had two things coming at each other, and they collide and they stop. So that would also be a completely inelastic collision. But in this case, if they stopped, then 100% of the kinetic energy is lost, okay? In this problem, and the one we saw in this week's lab, after they stick together, they're still moving. So there still is some residual kinetic energy left, okay? So we want to find how much kinetic energy is lost, all right? Now, it asks for the magnitude. And the reason is we just want to know how much, okay? So for example, if let's say 70 joules of kinetic energy is lost, okay, we already know it's a loss. We don't need to say it's minus 70 joules, right? So let's say if you lost $20 playing poker, you don't say you lost minus $20, okay? You already know it's a loss. All right, now, if you look through the book and you're looking for an equation for magnitude of kinetic energy lost, that might not be in the book. So we have to figure out, how do you find kinetic energy lost? So in blue, I'm going to make up some numbers. So let's say in my initial picture, okay, this is my before picture, let's say the initial kinetic energy is 100 joules. Okay. After the collision, let's say the final kinetic energy is 30 joules. Okay. How much kinetic energy is lost? Well, 70 joules. Well, how could you get the number 70 out of the 100 and the 30? Well, you did 100 minus 30. So that means to find how much kinetic energy is lost, you did K initial minus K final. So to find the kinetic energy, the magnitude of the kinetic energy lost, I need to find the initial kinetic energy and subtract the final kinetic energy. Okay, so here's my initial kinetic energy. So that's for number 2. That's for number 5. And then minus K final. So remember, the picture shows that they're stuck together. So M2 plus M5, they're stuck together. So they give you all the masses, they give you the speeds, but you don't have V final. Okay, so you have no idea what that V final is. So that means you have to use conservation of momentum for the collision. So the initial picture, I have P2 initial plus P5 initial is equal to P final. Okay, so looking at my picture, I have M2 V2 initial, because remember momentum is MV. So P2 initial is M2 V2 initial. P5 initial is M5 V5 initial. And then P final, they're stuck together. So that's why I have both masses times V final. Okay, so now when I put in the numbers, V2 initial is 50. But they told me that number 5 was headed to the left at 15 meters per second. So when I put in the number for V5 initial, it goes in as minus 15. Okay, so just do the algebra, solve this for V final, you get a number, and then take that number and put it right there. And that'll give you the amount of kinetic energy lost.